This is section 1.4, part B. We now look at how to go from the expanded form to the factored form of a quadratic polynomial. And our first factoring strategy is to factor out a greatest common factor, often referred to as the GCF. If I look at my first example, I'll notice that in both terms of this polynomial, 3x is a common factor. 3x goes into both terms. So I'll factor out a 3x. 6x squared divided by 3x is 2x, plus 9x divided by 3x is 3. And I can double check if I were to distribute, I would indeed get 6x squared here and 9x there. So you can always check by multiplying back out. Our second factoring strategy is factoring a trinomial. Notice we now have 3 terms. And for the moment, I'm just going to look at ones that have a leading coefficient of 1. So a 1x squared here. We'll use what I refer to as the sum and product method. First of all, when I have a trinomial, a quadratic trinomial, I'm always going to try to factor it in such a way that it's a binomial times a binomial. And I'm going to start with x in each one. X times x gives me that x squared. Now to figure out the two numbers that go at the ends of each binomial, I'm going to look for two numbers that have a sum of -4 and a product of -12. So two numbers that add up to -4, but when I multiply them, I get -12. This one's not a particularly challenging one, but in general, if you have a hard time coming up with these, concentrate on the product. List all the ways that you could multiply two numbers to get 12. 1 times 12, 2 times 6, 3 times 4. That's it, right? Now I do want a product of -12, so I know one of each of these products would have to have one negative factor. And I also know the sum is supposed to be -4. So looking at these, I'm thinking if I used this one and put a negative on the 6, now they do indeed multiply to -12. But if I were to add 2 and -6, I would get -4. So I'm going to end up with a +2 and a -6. X plus 2 times x minus 6 is my factored form. Again, you could check that by doing FOIL to multiply it back out. And you should see that you get the original x squared minus 4x minus 12. All right, what happens though if the leading coefficient is not equal to 1? There's multiple ways to do this. Some people use sort of a guess and check strategy, and if you've done that in the past and it works for you, that's fine. But I'm going to use more of an extended sum and product method. Here's how it works. Because I have a 4x squared, not just a 1x squared here, I can't immediately break this down and say I know what to start with, like I did with the 2x's there. Instead, I'm going to say let's find two numbers with a sum of -11. And for my product, I'm actually going to multiply the first and last coefficients, the 4 times the 6, giving me 24. So product in this method, you have to multiply A times C, or first times last. Looking at those, I'm thinking 3 times 8 definitely gives me 24. And if I made them both negative, I would still get a positive 24 for a product, but now they add up to a -11. All right, here's what I'm going to do with those values. I'm going to come back over to my original problem, and I'm going to keep my 4x squared. I'm then going to take my -11x, and I'm going to rewrite it. I'm going to break it down using the two values that we found here. -3x and a -8x. Notice I still have negative 11x. I've just rewritten it. And then I still have that plus 6 at the end. I finished this problem by using a strategy called factoring by grouping. I group the first pair of terms, and I group the second pair of terms. In the first pair of terms, there's a GCF of x, which I'll factor out, leaving 4x minus 3. There's a minus between the groups, so I'm going to factor a negative out. And then 8x and 6, I could also factor out a 2. That's going to give me 4x, and 6 divided by negative 2 would be negative 3. If I've done this correctly, the two binomials inside the parentheses should always match. And in fact, they do. So I'm going to factor out that common binomial, 4x minus 3, and then what's left would be this x and that minus 2. So there's the factored form of my original quadratic polynomial. Once again, I would encourage you to multiply that out, do the FOIL process, and you should find that you get exactly the original expression back again. The fourth and last technique that we'll look at for quadratic polynomials is factoring a difference of squares. If the form is a perfect square minus another perfect square, a squared minus b squared, then the factored form is a plus b times a minus b. Here's an example. Notice that the first term, 16x squared, is the square of 4x. So I'm thinking a is 4x. b would be 7, since 49 is the square of 7. Then I just follow my pattern here. A plus b would be 4x plus 7, and a minus b would be 4x minus 7. And there's my factored form. One thing to note here, you can definitely see where that 16x squared and that negative 49 come from. But notice that the negative 28x on the outers and the positive 28x on the inners would add up to 0, which is why we don't have a middle term on this particular quadratic. All right, so there's a brief review of factoring for you. Time to go do some practice problems and then come back for part C.